So let me show you what I'm building.
What is it, you might ask? No, it is not just a fancy pizza turner, although that is a pizza pan. Anyways, I was required to do something to make up for some time that I missed in school, and I realized that our physics lab was deficient when it came to teaching us about angular momentum. So I decided to build something that would demonstrate angular momentum. So let me show you how it works here. I have this push button, and this push button accelerates this dish, or disk, I should say, this disk. Right now, in its light form, it's just a 16-inch aluminum sheet with some holes in it, so it's very, very light. It doesn't carry a whole lot of momentum or inertia. And so I push the button, it accelerates very quickly. You can see the ammeter popped up to about a little over an amp, and then settled out for a steady state current of really low. Then you release the button, and it coasts down over time. Now there's an optical eye that goes through this outer row of holes in this dish, and that eye feeds a speed input to a computer that we can plot at school. If we don't have the computers available for that, then I have the ammeter to show how much current it takes to accelerate the load and then to keep it running at steady state. As I add more weight to it, it'll have a higher spike, and it'll take longer to come down to a steady state load. So you can add a bunch of weight to these rows here. There's 6 rows of holes. I still have to paint this to show which ones to use. And then you can take the same quantity of weight, put it in the center, or put it on the outside edge, the second to last hole, and observe the difference in how long it takes for the current to decay on acceleration, and then also how long it takes to spin down via the indication on the computer. The other thing I have is I have an internal resistor hooked to this switch that will act as like a dynamic brake almost. But the current, or the voltage from the outside of the motor, goes through 2 resistors I have inside here, which are currently too small. I need to put more resistors in here. I only have 2 ohms. I need about 12 to 19 ohms, somewhere in there. And so what happens right now is it decelerates way too fast. I'll show you. But you can watch the current spike as it goes through the resistors, and then decay away really fast. So there's the acceleration, starting surge. Here's the steady state current. You turn on the resistors, and I release the switch. Boom. See, it comes to a stop really fast. The more weight I have on the dish, the longer it will take for it to spin down. But I do want to get higher resistance resistors in here so that it takes longer to spin down with light load, so you have something that you can actually measure instead of a near instant stop. Anyways, this is, oh, I also have the speed controller I haven't mounted yet. This allows me, so if we put a lot of load on it, then I can accelerate them slowly so we don't burn the sucker out. If I want to just do coast down tests, there's no point in dealing with the big huge starting surge when you just coast down test. There you go. And that's it. What do you think? Pretty neat. Oh, I also got these ports here. This is just terminals for voltage across the motor. So instead of watching amperage, if you want to watch voltage, how much it generates on deceleration, how much it's seeing during acceleration or whatever, then you just hook a voltmeter to that. That's it. Thank you.